Asteroids, cold, rocky remnants of the early solar system, seem harmless as they drift through space. But these celestial wanderers hold the potential for unimaginable destruction. Throughout Earth's history, asteroids have struck our planet with devastating force, shaping its surface, altering its climate, and even causing mass extinctions. What makes asteroids so dangerous? How often do they collide with Earth? And what are we doing to prevent the next planetary catastrophe? To answer these questions, we need to dive into the science of asteroids and their potential to unleash Armageddon. Asteroids are rocky bodies that orbit the Sun, primarily located in the asteroid belt between Mars and Jupiter. They are remnants from the solar system's formation, leftover material that never coalesced into a planet. While most asteroids range in size, from a few meters to hundreds of kilometers, their small size belies their destructive potential. Not all asteroids stay confined to the asteroid belt. Gravitational interactions with planets can knock them out of their stable orbits, sending them hurtling through the solar system. Some of these asteroids, known as near-Earth objects, NEOs, pass close to our planet. While most NEOs are harmless, a small percentage have orbits that intersect with Earth's, putting them on a potential collision course. When an asteroid collides with Earth, the energy released depends on its size, speed, and composition. Even a relatively small asteroid can cause significant damage. For example, the Chelyabinsk meteor, which exploded over Russia in 2013, was only about 20 meters in diameter, but generated an explosion equivalent to 500 kilotons of TNT, roughly 30 times the energy of the Hiroshima atomic bomb. Larger asteroids, those measuring several kilometers in diameter, can cause global devastation. The most infamous example is the asteroid that struck Earth 66 million years ago, triggering the Cretaceous-Paleogene extinction event. This asteroid, estimated to be about 10 kilometers wide, slammed into what is now the Yucatan Peninsula in Mexico. The impact created a massive crater, unleashed tsunamis, ignited wildfires, and ejected so much debris into the atmosphere that it blocked sunlight for months, leading to a global impact winter. This chain reaction wiped out approximately 75% of all species on Earth, including the dinosaurs. Asteroid impacts are rare but inevitable. Earth is hit by small meteoroids every day, most of which burn up harmlessly in the atmosphere. Larger impacts, however, are much less frequent. Scientists estimate that an asteroid capable of causing significant regional damage strikes Earth every few thousand years, while planet-killer asteroids, those larger than 1 kilometer, hit approximately once every 500,000 to 1 million years. While these odds might seem reassuring, the consequences of even a single impact are so severe that it's critical to prepare for the possibility. Moreover, the vastness of space makes detecting and tracking potentially hazardous asteroids a challenging task. Thanks to advancements in technology, astronomers have catalogued thousands of near-Earth objects. Space agencies like NASA and ESA have dedicated programs to identify and track these celestial threats. Using ground-based telescopes and space observatories, scientists monitor asteroid orbits, calculate their trajectories, and assess their potential risk to Earth. Despite these efforts, there's still much we don't know. Smaller asteroids, like the Chelyabinsk meteor, are difficult to detect because of their size and speed. They can approach Earth undetected until it's too late. This was the case with the Chelyabinsk event, which caught the world by surprise despite being one of the most significant meteor explosions in recent history. The good news is that we're not entirely defenseless against asteroid impacts. Scientists and engineers have proposed several methods to mitigate the threat of a potential collision. One of the most promising strategies is known as a kinetic impactor. which involves smashing a spacecraft into an asteroid to alter its trajectory. In 2022, NASA successfully tested this concept with the Double Asteroid Redirection Test (DART) mission. The spacecraft collided with the asteroid Dimorphos, changing its orbit and demonstrating that humanity has the capability to deflect asteroids. Another approach is the gravity tractor method. This involves placing a spacecraft near an asteroid and using the gravitational pull between the spacecraft and the asteroid to slowly alter its course over time. While this method requires careful planning and long lead times, it has the advantage of being less destructive and more precise. For more extreme scenarios, some scientists have proposed using nuclear devices to either vaporize an asteroid or nudge it off course. While this approach is often portrayed in movies, it comes with significant risks, including the possibility of fragmenting the asteroid into multiple hazardous pieces. While asteroids are the most well-known impact threats, they aren't the only ones. Comets, which originate from the outer regions of the solar system, can also pose a danger. Unlike asteroids, comets are icy bodies that travel on highly elliptical orbits. Their sudden appearances and high velocities make them even harder to detect and deflect. Rogue objects, such as interstellar asteroids like Oumuamua, add another layer of uncertainty. These objects come from outside our solar system, traveling on unpredictable paths. While their chances of colliding with Earth are extremely low, their existence highlights the vast unknowns of the universe. The history of asteroid impacts on Earth serves as both a warning and a call to action. The Chicxulub impact that wiped out the dinosaurs is a stark reminder of the destructive power of these celestial objects. However, it also highlights the resilience of life and the importance of preparation. By studying craters like Chicxulub, scientists have gained valuable insights into the mechanics of impacts, the effects on climate, and the processes of recovery. These studies not only deepen our understanding of Earth's history, but also inform our strategies for preventing future catastrophes. Looking ahead, the field of planetary defense is poised for significant advancements. Space agencies around the world are collaborating on missions to study asteroids up close, develop better tracking systems, and refine deflection techniques. Private companies are also getting involved, exploring the potential of asteroid mining, which could simultaneously reduce the risk of hazardous objects and provide valuable resources. Public awareness and education are crucial components of planetary defense. Events like the Chelyabinsk explosion have sparked global interest in the asteroid threat, prompting governments and organizations to invest in research and preparedness. By staying informed and supporting scientific efforts, humanity can reduce the risk of an asteroid Armageddon. Asteroids are both a threat and a reminder of our place in the universe. They connect us to the early days of the solar system, holding clues about its formation and evolution. At the same time, they challenge us to think about the fragility of life on Earth and the importance of working together to protect our planet. The next time you see a meteor streaking across the night sky, remember that it's a fragment of the cosmos, a piece of ancient history that has traveled billions of miles to reach us. While most meteors are harmless, the potential for a planet-killer impact is a sobering reminder of the power of the universe and humanity's role in navigating its challenges. Stay curious, stay informed, and join the effort to keep our planet safe. Because when it comes to Asteroid Armageddon, preparation is the key to survival.